Good evening, everyone. Welcome to day 4 of our 15 days free training program on Python for AI. Before we move to day 4, let's quickly recap what we learned till now. So, till now, we studied data types in Python. So, we understood what data types are and why they are important, and also the fundamental data types. So we have 14 data types mainly, and they are classified into 6 main types. So in that, firstly, on day 2, we learned about fundamental data types. So fundamental data types are int, which are integer values like your 10, minus 25, 0. And we also learned about float values. Float values are real constant values or the values with the floating points like 3.14, minus 2.5, and any values with a decimal place. And then we learned about Boolean data type. So Boolean data type values are nothing but true and false values. And then in integer, after these we learned complex data type also. So complex data type values are having two parts, which is real part and imaginary part. So for example, complex data types are in this way. We can internally these values are stored in float values. So you can have it this way as well. So your j here is square root of minus 1. So 2 is the real part and 3 is the imaginary part. So we also looked at the number systems. So what are the number systems? There are 4. Firstly, decimal number system. And then binary. And then the third one is octal. And the fourth is hexadecimal. So we learned about all these number systems and we learned how we can convert decimal numbers to binary and decimal numbers to octal and decimal to hexadecimal. In the same way, we learned how we can convert them back to the decimal number system. And also we've learned conversions between these binary octal and binary hexadecimal, octal hexadecimal also. So in this way we learned them, and also we learned about the functions which will do the number conversions easily, like the bin, oct and hex. So these are the functions for number conversions. And then we started learning about sequence category data type. So yesterday we learned about the string data type. So we learned about the string data type. Mainly, sequence category data types are used to store sequence of values. So if you want to store a sequence of characters like a name or a sentence or a address, you can use sequence category data types. So in that, the operations which are supported are indexing, that is obtaining a single value. So from a string, you can just obtain a single value by doing indexing. So in this way, I can take the index of the value I want and I can put square brackets, and this way I can perform indexing. And then moving on, it also supports slicing. Slicing is nothing but obtaining a substring. So substring is nothing but a smaller string inside of your main string. So to obtain this, we can perform slicing. And then we learned about mutability and immutability. Mutability is nothing but we can modify that specific data type. And immutability is nothing but one data type is said to be immutable if it cannot be modified. So mutable means it can be modified. And then we've looked at the coding part of string data type, and we also performed indexing, slicing, and the other operations on string data type. And the other remaining data types in sequence category data types are bytes, byte array, and range. So today we are going to learn about these data types in sequence category data type. So moving on to the date 4 topic. So firstly, bytes. So this is a very interesting topic. So bytes is nothing but this is closer to how your computers actually see data. So computers see data in the form of bytes. Imagine you're sending some image to your friend on WhatsApp, let's say. So when you send a photo on an WhatsApp or any other platform, so internally this photo is not stored as an image. It is stored as numbers. So those numbers are called as bytes. So the images are stored in form of bytes. So these bytes are used to store sequence of positive integers or numerical integers in the range of 0, 256. That is, it stores values from 0 to 255. And bytes is a predefined class and it is treated as sequence data type. So to represent the elements in bytes data type, we don't have any symbolic notation, but we can convert other data type elements into bytes data type using the function bytes, parenthesis. So mainly the syntax of this function is like an iterable object in int. So you can give any iterable object which consists of integer values for bytes, and then it will convert it into bytes. So bytes data type is immutable. So you cannot modify the bytes data type values. So if it has some values like 10, 20, 30, you cannot modify them once they are created in bytes. And that is why the item assignment is not possible in bytes data type. And then moving on, the objects in bytes allow us to place unique elements or duplicate values also. So in your bytes data type, we can have unique elements, so like the distinct elements, or you can also have duplicate values. That is the same values twice or thrice. And the operations you can perform on bytes is indexing, that is obtaining a single value. And slicing is also possible on your bytes data type. Slicing is nothing but obtaining a substring or a group of characters. So you may think, so why only 0 to 255 in your bytes, right? So why it is because as we learned in the first class, 1 byte is equals to 8 bits, right? So as 1 byte equals to 8 bits, when you take like 8 bits, so in this place, you will just fill with zeros and ones. So these are the bits, right? So this is 8 bits. So the combinations you can perform to get from 0, 0, 0, 0, 0, 0, 0, 0. So 8 bits the combinations will start from all zeros and it will go on till all ones, right? So the combinations will go on from all zeros to all ones. So the formula for finding the combinations is 2 power 8. So 2 power n. So that is why 2 power 8 is equals to 256 values or combinations. So if you look at here, if there are all zeros, so what will be the value? 0 only, right? So if you look here, all ones. So this bit is 2 power 0. So this bit is 2 power 1. Then this is 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. So simply to write it, 2 power 1, 0 is 1 and 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32 and 2 power 6 is 64 and 2 power 7 is 128. So these are all values. So when you convert into binary, we'll take these values, right? So if it is 8 bits from 2 power 0 to 2 power 7, the values will be. So all are ones. So all are ones means you need to add all these values, right? So traditionally, if you want to do it, so it is 1 into 128 plus 1 into 64 plus 1 into 32 plus 1 into 16 plus 1 into 8 plus 1 into 4 plus 1 into 2 plus 1 into 1. So all this, if you add it, you will be getting 255. So that is why your range will be from 0 to 255 values. And all these are the 256 values or combinations we get from 8 bits. So it will start from 0 to 255. So to summarize it, bytes is used to store sequence of positive numerical numbers, integers, which stores values from 0 to 255. And bytes is immutable, so you cannot modify the values in bytes. And that is why it does not support item assignment. And it supports only indexing and slicing. And also, this is mostly used in file handling. So main use cases of bytes is file handling and then network programming and also image processing. All the images are stored in bytes, right? So it is used in image processing and also encryption. Like if you know anything about cryptography or your QR codes, right? So that is encrypted values, right? So in that also you'll be using bytes and also in AI. So in AI, when you want to load images, those are first bytes and you will process those. Excuse me. So bytes is used when you're dealing with binary data. So when you're dealing with binary data, bytes is used. So binary data is nothing but your zeros and ones. Like we got to know about the 8 bits, right? Just now. So when you're dealing with all the binary data, you will be using bytes. So moving on, let's know about some examples of bytes. So basically, how you can create a byte is you can give b equals to, let's say, some variable b, that is bytes function you can use with parenthesis, and inside of this parenthesis you can give some list of elements. We can give any iterable object, right? So here my iterable object is list. You can give a tuple also. So here I'll print b. So what do you think my output will be? The output will be B, A, B, C. So why this is because internally here 65 is mapped as A character and 66 is mapped as B and 67 is mapped as C. So these mappings occur in some system called as ASCII. So these are the ASCII values of your characters A, B, C. So ASCII is nothing but American standard code for information interchange. So ASCII system is a system which assigns numbers to your characters. So if you see here the table, just don't worry about these numbers. Just look at the characters here. So for each character, what our ASCII system does is it will assign a value in your decimal number system. So if you see here, the capital A is written as 65, right? So A is mapped to 65. So in this way, and your capital B is mapped to 66 and capital C is mapped to 67. And if you see here, we have numbers also. So these are treated as characters here. We also have special characters. So computer stores everything as numbers, right? So internally computer stores everything as numbers. So even if you give like the characters, special characters or numbers or all the uppercase letters or lowercase letters, it will internally store numbers. So that is why ASCII is there. So ASCII was created in 1960s. So how it mapped things is, so ASCII values are basically from 0 to 127 as you can see here. In decimals it will start from 0 to 127. Okay. So the first 0 to 31 decimal numbers were reserved for control characters. So if you can see here 0 to 31. So these are control characters like backspace or horizontal tab, like the tab space, getting into the new line, and shift in, shift out, cancel, and start of heading, start of text, end of transmission. In this way, these are some operations. So these are control characters. When you print these are not basically visible. Okay, most of them are not visible. So these are the control characters. These control characters are assigned values from 0 to 31. And moving on from 32 to 126, all are printable characters. So if you see here, yeah, from 32. So the space, when you click your space bar, we'll get a space between the before letters and after letters, right? So that is printable as you can see that. So the 32 is space value. And moving on to all the values, these are all printable characters. So these are special characters which we can see when we type these. And then we have numbers, and then we have colon, semicolon, less than, equals to, greater than, question mark, and at the rate. And then here from 65 to 90, we have all the uppercase letters. And then we have the brackets and the power symbol and also minus. And then from 97 to 122, we have all the lowercase letters. And then we have curly braces. And then we have the OR operator and also the last delete function. So from 32 to 126, all are printable characters. So all these printable characters are given numbers from 32 to 126. So above that, all are extended ASCIIs. So this is basic understanding. You don't need to remember all these numbers. Okay, first let's look at the coding part and then you'll get better idea of it. So here if you see, so we have a list. First, we can create a list or a tuple and then you can create bytes data type from that list or tuple as they are iterable objects. Okay, so here I've created a list with elements 10, 20, 45, 56 and 256. Okay, so if I run it, so initially it is list data type only and I'm giving bytes function for that list. So this bytes of your list. So this list LST, which is 10, 23, 45, 56, 256. Okay. So these values, this is being bytes of this list is being assigned to your variable B. Okay. So if you try to print that, you can see bytes must be in the range of 0 to 256. So that means you can only have values from 0 to 255 because as you know the end index is excluded, right? So we can only have values from 0 to 256 minus 1, that is 255. But we have 256 value, so that is not possible. So that is why we got the value error here. And then moving on, here you can see we have a list 10, 0, minus 23, 45, 56, 255. So do you think this will be converted into bytes without any error? Let's just find out. So I'm converting this list. So initially it is class list and then we'll be converting it into bytes using the byte function and we'll assign that value to the left hand side, which is variable B. So we have B. So you can see we got a value error and the range should be from 0 to 256 only. As we learned, bytes will only allow the positive integer literals or integer values, right? So as we have a negative value, will get error, the value error, and it should be in the range only. So that is also not possible. If you see here, we have values 10, 20, 23, 256, 56, 255. So this, as you can see, it is in the range of 0 to 256 only. So now this will be printed neatly. So initially that is a list and then we have bytes and that is converted into bytes. So in depth, we'll learn about this. So basically it is in class bytes, right? So let's just know how this works internally. So as you can see, we gave a list LST equals to 10, 0, 23, 45, 56 and 255. So this is our list, right? And then we are giving a B variable and that is equals to bytes of your list. So that is, we are converting this list into bytes and we are assigning that bytes value to B, variable B. And when I try to print B, I'm getting output B slash n slash x00 slash x17 dash 8 slash XFF. So let's just understand this in depth. So before decoding this, let's mainly understand three things we need to know about this ASCII and bytes and how they are connected. Okay. So the first thing, what is ASCII? As you know, ASCII will map your characters to some numbers in the decimal number system. So it is just a mapping system. Each character will have a number. That is the decimal number, basically. That's it. Each character will have an assigned number or map number. So if you see your character A, it is given to 65. As you can see here, character A, capital A is mapped to the value 65. And if you see capital B, it is mapped to 66. And if you see the small letter, character A is mapped to 97. And in the same way, if you see 0, here we have the 0. And numbers also mapped to their equivalent decimal numbers. So 0 is mapped to 48, and then the space value is mapped to 32, and also less than symbol is mapped to 60. So in this way, each character is mapped to a number. So it is nothing complicated, just mapping. So ASCII values are from 0 to 127 numbers. So it will start from 0 and it will end till 127. Now let us know what is bytes. So what is bytes? It's just the number from 0 to 255, right? So what bytes does is, it will store numbers, not characters, just numbers. So your bytes will store numbers and not the characters. So how you can map these both? So ASCII numbers are from 0 to 127 and your bytes values are from 0 to 255, right? So if you see the number line, this is till 255, right? So all your ASCII values will fit inside your bytes, right? So your bytes can represent your ASCII numbers. So the ASCII characters can be stored inside of a byte. As you see, the range 0 to 127 falls in between 0 to 255. So what ASCII system does is, it will give each character an ASCII number and that can be stored as bytes. Let's clear it. So basically, we have a character. So that will be assigned an ASCII number and we can store it as bytes. So if you take A, capital A again, so the ASCII number is 65 for A. And you can store this as byte 65. And basically, there are two functions when you want the character to ASCII or ASCII to character values. So firstly, we have character to ASCII number. I don't know what A is mapped to, right? So if I want to know the ASCII number for which my character A or B or 0 greater than less than it's mapped to, I can use a function called as ORD. So what I can do is, I can just print the function ORD. Inside of that, I should give only just one character, that is my A. So I can just directly print it. The output I'll get is 65. Here only one single character should be there. And when I want to know for some number what character is given. So ASCII number to character, let's say. So I have some number 48, let's say. So for 48, what character is given I want to know. So let's just use the function character. CHR function is used to find that. So CHR of, if I write 48, if you see here 48 is mapped to 0 character, right? So what I'll get the output is, I'll get the output 0. So in this way, you can find what character has the ASCII number and what ASCII number is mapped to which character. So now let's understand how bytes is working. So let me just write the example we used before. The list 10, 0, 23, 45, 56 and 255. Now I will convert this list into bytes using bytes function. Bytes LST. Okay. Now I'll print by B, which is the bytes value of list. So my output I got is B. This is the same output I got from the spider environment. So don't get confused. So this is the value I got. So what's happening here internally? Now let's just decode what's happening with the output. First, let's match each number, okay? So here we have a 10. So 10 means in the decimal numbers we should check 10, which is line feed. Line feed is nothing but a new line. So 10, which we gave in the value here, 10 is mapped to a new line character. So here you can see the starting, we have /10, that is our 10 value. And then moving on, we have 0. So 0 here is /x00. If you see the hexadecimal value for 0, what you should do, if you want to convert decimal number, you should divide that with 16, right? So 16 zeros are 16 zeros are 0 minus 0 only you'll get. If you try again, so that's how you'll get 0, 0, right? So x00. That is how it's changed into hexadecimal value. And then we have 23. So 23 is written as the next hexadecimal value, which is x17. And then we have 45. In decimal numbers, where is 45? So here we have 45, which is a hyphen. Okay, so that is why here the hyphen value is our 45 value. And then we have 56. So if you see, where is 56? Here we have 56. It is the 8 number. That is a character. So 56 is mapped as 8. And last, XFF. So we have 255 value that is mapped as XFF. So why do you think you have XFF? So that is the hexadecimal representation, right? So if you take 256, 16, 16, 16 is at, sorry, 255. 16, 16 is 256 will be. So we'll take 16, 15 is, that's 240 and the remainder will be 15, right? Again, you will divide with 16. 16 zeros are 0. The remainder will be 15. So again 15. So you'll take from bottom to top. 15, 15 means, you know, right? A is 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So the hexadecimal representations we learned on this day 1, right? Day 2, right? So that is that. So that is why when we are representing, we'll have some X here and FF is the value of, combinedly it is the value of 255. So in that way, you will be getting the outputs. What happens here is, so here we got some values as hexadecimal values and some values directly, right? The characters are printed, right? So why it is happening? It is because when a byte corresponds to a printable ASCII character. So when a byte number will correspond to a printable character. So printable characters, as we learned, the characters from 32 to 126. So 32 to 126 characters are printable characters. So when your byte number, any number between this 32 to 126, if we have, that is a printable character, right? So it will show directly that character. Let's say some number 79, let's say. Between, in this range, we have a byte number that is 79. So what it will be? 79 here is character O, capital O, right? So directly it will print O. But if we have any byte number which will correspond to non-printable characters. So what are non-printable characters here is the control characters. So we have 0 to 31 are control characters, right? So these are the characters which we cannot print. So these are non-printable. So what happens for these characters is when I want to print, let's say 3 value, we will represent this value, which is a non-printable byte value. So the ASCII representation of 3 byte number is a control character, right? So that won't be printable. So it is non-printable. So we will represent it in a hexadecimal number system format. So what we can represent it is, we should convert it into a hexadecimal format. So how you can do it? You can divide 3 with 16. So 16 zeros are 0. So 3, and we can, then we will take from bottom to top. So the value will be 0, 3. If you take, let's say 17. So 17 is also a control character, right? So this is not printable. So in your list, let's say we have 317 as we are doing it right now, and we converted this into bytes, let's say. So how we can do it? So 3 is not printable. So the equivalent, which is a hexadecimal value, will be printed in place of 3. So it will print x03. And we have 17. So 17 is also a control character. So you cannot print this also. So that is a non-printable character. So that is why you will convert this also into hexadecimal format. So hexadecimal means you will divide with 16. So that is 16 ones are 16. Remainder will be 1. And then again you will be doing 16 zeros are 0. Then again 1. 16 1, 16, and the remainder will be 1 first. And again you will divide with 16 zeros are 0 and the remainder will be 1. So how you can write is /x11. So in that way, that will be printed. As these are non-printable characters in the ASCII system, that will be changed into hexadecimal values. So here the concept is bytes will not store characters. It will store the raw binary data. So when the byte number, when it is a printable character, it will directly print your character. So it will check firstly in your list what number is there. It will check, like let's say 36 is there in your from list, you convert it to bytes, right? So if you take 36, that is a printable character. So it will directly check what character it is representing, and it will print that character. Here we have dollar. So it will directly print dollar in this place. So this is the 3, 17, 36 list, right? So this is the 3 value, 17 value, and 36 value. So if it is a non-printable character like 3 or 17, which are control characters, so you cannot print them. So that will be printed in hexadecimal format. So internally what happens is each number will become 8-bit binary number, because we'll take the combinations, right? So 0 to 255, it will have 8 bits combinations. So all combined together in a memory as a continuous byte sequence. So even though it will display like this in a hexadecimal format or the dollar format, when you try to print it, So let's say you give b equals to bytes of, so same example, let's take 3, 17, 36. If you print b, if you try printing b, you will get in this way. But if you try to print the bytes value, which is b variable with indexes, it will give your output 3 only. So even though it will display it in this format, the bytes format, internally it will store the number 3 only here for you. Let's just understand the code and you'll get a better view of what I'm telling. So as you can see here, the first example 65, 66 and 67. So I've taken a variable equals to the bytes of the function, and inside of that I've given the list 65, 66, 67. As you know, if you go here, the value of 65, 66, 67 are capital A, capital B and capital C, right? So what will happen here? First we'll assign them. After assigning, let me print A. Okay, as you can see, we got the output B, A, B, C. So here, our 66 is printed as A here, and then our 65 is printed as A, and 66 byte value in ASCII, that is a character which is B. So it is printed as B, and 67 is printed as C. Okay, so that is why how it is mapping. Using the ASCII characters, it will take your decimal number or the byte number first, and it will map with the printable character. As this lies in between 32 to 126 range, which are printable characters, it will give our printable character here. So A, B, C, these are printable, right? So it will give in that way. But if I try to print a variable of 0. So internally, if you check it, it will store 65 only. Internally, it will store 65 only. But if you print the bytes values, it will be given as B apostrophes, capital A, capital B, capital C. So these are the ASCII characters of your number 65, 66 and 67. Okay. So I've told you, if I want to convert, like I want the ASCII number for this character small a. So what I can use is I can use the function ORD. So I used ORD of character A and I got 97. And if I try using another character, let's say capital Z, let's say. So here, as you can see, we got 90. So if you see here, where we have the capital Z, so we have the capital Z is mapped to the ASCII number 90. So that is what we got. So now I want to check for the number 97 what ASCII character is there. So this is the reverse of what we are doing here. So if I want to check that, I should give CHR function. In the parenthesis, I need to give 97. So let's just take 97 value. So what is 97? It is given as ASCII character, that is small a. So let's check. In 97 decimal, the character is small a. Okay. So in this way, I can find the ASCII, the corresponding ASCII number or corresponding ASCII character. And if I try, so we have already tried this. So the value of 255. So ASCII numbers are only from 0 to 127, right? So after these also, there are no corresponding characters for numbers. Like if you see at bytes, it will end at 255. So from 128 to 255, we don't have any corresponding ASCII values. So 128 to 255, we don't have any corresponding ASCII characters. So what it does is, this is also treated as non-printable. And what it will do is, it will convert these numbers into hexadecimal format. So as we did, we need to divide 255 with 16. So as that base is 16, right? Hexadecimal. So we'll divide with 16 when I want to convert it. And what I'll do here, 16 15s are 240 and the remainder would be 15 again. And then 16 zeros is 0. So 15 minus 0 will be, remainder will be 15 only again. So the 15 here, from bottom to top I'll take. So 15, 15. So the value A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So I'll take the F values. F. I can write it as capital or small, but here we'll get output as F. So to represent hexadecimal, we will just use 0x or 0 capital X, right? So in that way, it will give here XFF. So that is how we will get the values. So next, this is the example we've done before. So here, let's recap. So here the 10 value, which is a control character. So if you go back, so 10 is a line feed, that means new line. So for new line, the symbol is /n. Okay, so for 10, it is /n. And for 0, this is also non-printable, right? So when you do it into hexadecimal form, that will be /x00. And when it comes to 23, so let's try 23. So 16, ones are 16, the remainder will be 7. And when you divide with 16 again, 16 zeros are 0, 1 minus 0 is 1 only. So you'll take from bottom to top. So that is how you got 17. So that is the 17 here, /x17. So for 0, it is x00. And for 23, it is x17. And for 45, so that is a printable character, right? So 45 here, where it is 45 here is hyphen. So 45 represents the hyphen here. So after hyphen, so 56. 56 is also a printable character. If you check it, 56 is 8. So it represents the character 8. So 56 is the 8 here. So 8 is done. And 255 we just did it. That is /XFF. So that is the hexadecimal equivalent. So that is how you will be getting the output in bytes. When you convert these numbers to bytes, the output will be like this. But internally they'll be stored as these decimal numbers only when you try to access it. So in this way, when you try accessing it, so this is the same indexing like we learned in strings 0, 1, 2, 3, 4, 5, right? I tried accessing the first index element, which is 0, and that is how internally it will still store the values. So moving on to the next example, we have a list 0, 3, 45 and 255. So what happens here? So in this, I just wanted to add a point. So in non-printable characters also, so I told 0 to 31 are control characters and these are non-printable characters, right? So most of them are non-printable characters except some values like 9. So 9 is printed as T because if you look at the table here, 9 is as the horizontal tab, right? So that is a value in which we won't get like /x09, we won't get. We'll get /t. That is why, because some non-printable characters, they have standard escape sequence. This sounds a little complicated, but it's just for 2-3 characters, okay? So these characters like tab space or slash or new line like 10 we printed just now, right? Slash n. So these values and one more value is 13. So 13 also is printed as slash r. So why this is because some characters are these have standard escape sequence names. So these are used for pre-processing. So in text pre-processing, we will use these. So they have standard escape sequence names. So that is why Python will print them in readable escape form. So this is a readable format, right? So only these 9, 10 and 13 in the range of 0 to 31 control characters. So only these will be printing these values. So Python prints the readable escape form. So only for these characters, it will print this way, and other all characters will be converted into hexadecimal number system only. Only these will be printed as these because they have standard escape sequence names. Okay. Now let's continue with the points we are going with. So this example, we have a list of 0, 3, 45 and 255. So I'll print it. So initially it is a list and then we are converting this into bytes. Okay. So I converted this list into bytes and I'm printing that. So what we got here? So first 0. So that is non-printable character. So 0 to 31 are non-printable. So these will be converted into hexadecimal forms. So 0 is hexadecimal if you try dividing with 16. So 16 0 is 0 and 16 0 0. So here, so 0 will be printed as slash x 0 0. So that is what you got here. The first one slash x 0 0 and 3. When you try dividing 3, so 16 0 0 3. So 16 0 0 again you will divide and it will take from bottom to top. So for the 3 value it will be x 0 3. So that is what it is printed here. And when you go to 45, so from values from 32 to 126 are printable, right? So you'll directly print the character. That is the ASCII mapped character. So if you see 45 again, that is a hyphen. So that is why we have a hyphen here. So that is a hyphen. And when it comes to 255, as we did already, XFF. Let's try printing the values which I've explained just now, like let's say 9. These are exception cases and non-printable characters, right? Let's print these ones and 10 also. Let's try printing them. So if you see here, this is firstly our 0 value and then we have this x slash x 03 is the value of 3 and then 45 is a printable character, so it is printed in hyphen, only the hyphen, and then 255 is printed as slash x ff slash x ff, and then I've told you, right, 9 is printed as slash t, 10 is slash n, and 13 is slash r. So as you can see, we have 9. So slash t is the 9 value, slash r is the 13 value here, and slash n is the 10 value. So as these have standard escape sequence names and they are used in text processing, so Python will just print them in the readable escape form. That is these values. So I want to access the values directly. So if I print it just b, I'll get these, right? So if I want just one value, I can just do the indexing. So let's say 2. So 2 values 0, 1, 2. So the index is 0, 1, 2, 3, 4, 5, 6. So I'm trying to access the index 2. So 45, it will print 45. So that is what. So if I want to print all of the numbers which are stored internally, I can just use some for loop. So this is a simple for loop. What happens is it will check. So here we'll take some variable name that is value in B. This is the iterable object. So we can iterate, right? From here we can move on to next, next, next. So that is an iterable object. So for value in, so basically internally, this is how it works. So it will iterate. So internally it will do this and print value. So how this for loop works is, firstly in place of value it will take the first value. So for 0 in your list, print your value. So first it will be 0. So it will print 0. And then it will move to the pointer will move to the next one. That is 3. So for value 3, so the value, next value, it will print that. That is 3. It will print 3. And then moving on, your pointer will move to the next number. From here, it will move to the next number, that is 45. And in place of value, it will consider 45, print 45. And in the same way, it will print all the remaining values. So it will just iterate, and for value, it will start here and it will go on iterating and it will print all the values with the for loop. So to get the internally stored values, I can use this for loop. So let's just print it. We will get all the values. As you can see, 0 and then 3 and then 45 and then 255 and then 9, 13, 10. In this way, I can print our internally stored values without just getting the byte values. So here you can see I have performed indexing operations. So bytes will allow us to do indexing and slicing, right? So here I'm trying to access the first element with the index value 0. So let's just write. So these are the values. So 0 means, so the index 0 represents to the value 0. If I print it, I'll get the value 0. And if I try to print B, so when you're indexing, you need to give the variable name and your square brackets. Inside of that, you should give index. So here I have 3 is my index. So these have the values, right? So the byte values. So you'll take the variable B of 3, that is 255. So it will print 255 here. Here we got 255. So now negative indexing. We just learned about negative indexing, right? Yesterday in the strings. So from backwards, the negative indexing will be done. Let me just write it. So from the backwards, it will move forwards. So right to left. So negative indexing will start here. -1, -2, -3, -4, -5, -6, and -7. So now I'm trying to get the value B of -1. Okay. So -1 is 10. So the last value, right? So we got 10. And I'm trying to get the value B of -4. So -4, what is the -4? 255 is the -4 index value. So if I try to do the indexing, so I'll get 255. If I try, let's say, print off the variable name in that square brackets, -7, let's say. So I'll print it. So -7, what is the -7 value here? 0. So that will print the 0 value. So then moving on, this is slicing. Let me clear these. Okay. So now I'm trying to slice. So what is the values from? So this is the beginning index and this is the end index, right? So as we learned yesterday, we will get the elements from beginning index to end index minus 1, right? So beginning index is 2, end index minus 1 means 4 minus 1, that is 3. So 2 index to 3 index will get to print. So here 0, 1, 2, 3, 4, 5, 6. Okay. So beginning index is 2 and end index is 4. Your end index, that is 4, will be excluded. So from 2 it will start and before 4 only it will stop. That is still 3. So it will print 45 and 255. So this is how we can do slicing. So you see here we got the byte values. If you try decoding them, the hyphen value, as we learned, that is 45, right? And slash xff is 255. So it is given in the byte format. If I want to print the internally stored values, that is 45 and 25, I can just use our for loop, just how I used before. I'll use for values in B 2 is to 4. That is this range 2 is to 4. It will first point to 45 and it will print 45. So what it will do is first it will point to 45 and it will print 45, and then this is a iterable object, right? It will move, the arrow will move here, and in the for loop it will move to the next element and it will print the next element in a new line. So that is how it is works. If we try to run it, as you can see here, we got 45 and 255. So we can also try to reverse our bytes data type. So to reverse, as we learned yesterday, what we can use is hyphen hyphen minus 1. So why? The step value is negative, right? So we will move from right to left. So beginning and index will be default value. So beginning it will start from 0 and ending index is the length of it, that is 7. So your values will be from here to here. But as we are starting from right to left, as it is a negative step value, so it will print 10, 13, 9, 255, 45, 30. But if you try to print directly, you will get the byte values, right? So how you will get is 10. 10 means slash n. So B of slash n, and 13. 13 is written as slash r, and 9 is written as slash t, and 255 slash xff. I'm just writing what we learned till now, okay? Don't worry. 45 is the hyphen value. You can check these values with the ASCII table, or also if it is not printable, you can just get the hexadecimal values. So 3 is slash x03 and 0 is slash x00. So if you try to print the byte value, you'll get in this way. So let me print it. Okay, so I'm getting the reversal. So as you can see, so the output we thought we got it. So here it will print from the reversal of the bytes data type, right? So from right to left it will print, that is back to front or end to beginning. So 10. So mine slash n is 10, and then 13 it is slash r is 13, and then 9 is slash t value, and then 255 is slash xff, and 45 is your hyphen value, and 3 is slash x03, and 0 is slash x00. Okay, so that is how we got it. So if I want to print these direct integer values, I'll just use the for loop like we used here. So let me just run this loop. So this is the reversal of values. So the iteration will be starting from back to front, right? So it will be at 10. First it will print 10 and then it will move right to left. That is 13. And then it will go to 9. It will print 9 and so on it will print. So if you want to see the output, so this is the output. As this is a reversal mechanism, it will go from right to left or end to front. So 10 and then 13 and 9 and 255 and 45, 3, 0. So that is how you got it. So this here, it will print all your values. Just from left to right, it will print all values in byte format. If I want the internal values, what I'll do is I'll use a for loop. So for some variable, it can be not just val, I can take I also. So for I in B colon colon, or I can use single colon also, it is fine. So that will also give all the elements in our bytes or string or whatever. So I'll write colon print I. So we just replaced the val variable with I here. So what happens is I, firstly it will point to 0. So there is no step, right? So positive step only internally by default. And it will go from left to right. So it will go from left to right. So firstly your I will point to the first element and it will print of 0. So it will print 0 and then it will move as it is a loop and iterable object. It will go to next and it will print 3 and 45 and next 255 and 9, 13, 10. So in this way we'll get the output. So let's just run it. So you got the output, the same out. So you'll print all values in this way. So if you want internal values, you can use some for loop and print it. If you want the byte values, you can just print the variable name of the values you want to print. You can slice it or indexing you can use or else others too. We will learn about tuple, but first basically tuple is used with a parenthesis and the elements are divided with commas, okay? So we are just using it. And this is a tuple. I've created a tuple and I'll try to print it. Wait. So this is a tuple and this consists of string and integer values. If I try to change it into bytes, the string object cannot be interpreted as integer because bytes will only take values that is positive integers only. And the range is from 0 to 256 only, right? So it will take only these values. So as it is a string, so it cannot convert neatly to bytes. So here that is why we are taking all integer values in the next example. So 10, 23, 45, 67, 67. So your tuple can also have duplicate values. So first we have a tuple. It is in a class tuple and I am converting this into bytes. So B1 is the variable for which I am assigning this bytes of this tuple and I've assigned and then I'll print it. So now that tuple is converted into class. So what happened here? So first your 10 value, as you know, it is a non-printable character, but it is represented as a new line, right? So slash n. So B of slash n is 10. As you can see here, slash n is 10. And 23 hexadecimal value. So this is non-printable, right? So you need to convert into hexadecimal. Hexadecimal means you need to divide with 16. 16, 1 is a 16 minus 7. So that is the remainder. 16 1 is a 16. 23 minus 16 is 7. And then again you will divide with 0. 16 0 is a 0. 1 minus 0 is 1. So from top to bottom 17. So that is hexadecimal value. So slash x17. So that represents my 23. And again 45 will have a hyphen. So hyphen represents 45 here and 67. So this is a printable character, right? So let's just go here. So if you see the 67 here, that is a printable character and it is corresponding to our capital C. So C will be printed in place of 67. Okay. So in place of 67, we will get a C. And we have one more 67. So one more C. So this is the output you'll get /n/x17 hyphen CC. So that is the value you got for this tuple. And moving on, I want to print all the internal values in this bytes data. So how I can print? I can use a for loop and print it. So I got 10, 23, 45, 67, 67. If I try to print the type and the memory location of it, so this is how the byte will be. And it is in a bytes data type. And this is the memory address. So using ID of parenthesis, you can get the memory address. And using the type parenthesis, you can get the data type of that variable. And here I'm trying to do the item assignment. So as you know, bytes is not mutable. So that is bytes is immutable, right? So you cannot perform. So you cannot do the updations. So for B1, that is here B1 means first, that is 10, right? So 0, 1, 2, 3, 4. So the for 0 index, I'm trying to give 100 value. So I want to change this 10 with 100. But we'll get a type error because bytes is immutable and it will not support item assignment. So that is why. Let's learn what is byte array. So now byte array is similar to bytes. So it is almost similar to bytes, but there is one difference, that is bytes is immutable, right? But byte array, this is mutable. So if I change one element in byte array, do you think the memory address will change? It won't change because byte array is mutable, right? In the same address location, in the same memory address location, my value will be updated. So byte array exists mainly for performance optimization. So byte array is used for performance optimization. So if you think bytes is like some PDF file. So PDF file is not editable, right? So that is why, like the same way, bytes is immutable. And your byte array is just like your Word file. So Word file or Word document is mutable, or you can change, or once it is also saved, you can edit it, right? So that way your byte array is. If you think bytes as a PDF file, that is immutable, and byte array is like a Word document which is mutable. So now let's know in depth. So byte array is a predefined data type and this is treated as sequence data type. So the purpose of byte array is similar to bytes, that is to organize sequence of positive numerical values ranging from 0, 256, that is 0 to 255 values only. So this is also used to organize sequence of positive numbers from 0 to 255, and to store values in objects of byte array data type, we don't have like symbolic notation, like directly for string we have apostrophes, and for list we have square brackets, and tuple we have parentheses, like. So directly you cannot do it. You can use byte array parenthesis function to change any list or tuple to your byte array data type. So the byte array belongs to mutable because it will allow us to perform updations or modifications. And the operations which I can perform on byte array are indexing to obtain a single element or single character, and slicing, it is to get a substring or a number of group of characters like 3, 4 at once. If I want, I can use slicing. And the objects in byte array will maintain insertion order. So what is an insertion order? Insertion order means in whichever order I will insert the elements, in that order only the elements will be displayed on our screen. So in whichever order I'll insert into the data type, in the same order in our output also that will be displayed. So the values will not be shuffled or jumbled. So just the main difference between bytes and byte array is it will perform the same purpose. It has the same purpose to organize sequence of positive numerical integers. But the main difference is bytes is immutable and byte array is mutable. So the updations which we cannot perform with bytes, we can do that with byte array. So let's know how we can use this. Let's move to the coding part. So byte arrays. So we have a list here. So from list and tuple only, we can convert to byte array. So here we have a list. First, now I'm trying to convert this into byte array using the byte array function of list. But it will not happen because we'll get a value error because the bytes must be in the range of 0 to 256, right? But we have a -2 here. So that will not be possible. So we'll get an error with this. And if I try to do this, we have a list with values 10, 20, 30, 40, 256. So if I try to convert that to byte array, it will not possible because we'll get a value error, that is the range should be in 0 to 256. That is the value should be from 0 to 255 only. But we have a value 256 here. So that will not be possible. We'll get a value error. And moving on, so these values are nice. So this is in the range of 0 to 256. So the values are from, it ends at 255, right? So 10, 20, 30, 40, 50. 255. So we'll convert this into byte array using the byte array function, and I'll assign that byte array value to B, and I'll print B now. So if I print B, as you can see, it's given in a byte data type. Like how we get in the byte, in the same way we got the value here. Here if you try to understand it, so 10 is written as /n. Okay, 10 is /n. When it comes to 20, so 20 is also non-printable, right? So what you'll do, you'll get the hexadecimal equivalent of 20. So how you can write 20? You can divide with 16 first. And 16, ones are 16. The remainder would be 4 because 20 minus 16 is 4. And then you will try again with dividing with 16. So 0. 16 zeros are 0. You'll get -1. Sorry, -1. So that is the remainder. We'll go from bottom to top. So you'll write /x14. So that is what you have here, /x14. So that is the equivalent of 20 /x14. And moving on to 30. 30 is also not printable, right? So you'll get the same hexadecimal equivalent of 30. So I'll divide 30 with 16. 16 ones are 16, 16 twos are 32, right? So you'll divide with 16. And when you give 30 minus 16, we'll get 4. Sorry, 14. So the remainder will be 14 here. And again 16, 0 is a 0. And the remainder will be 1 here. So I'll take from top, bottom to top. That is 1 and 14 I got. So as you guys learned yesterday, that is on day 2. 14 means in hexadecimal number system, it is capital E or small e, right? So it is basically value E. So in place of 14, you will write E. So here we'll get slash x1 E. In place of 14, I'll write E. That is what we got here, slash x1 E. And if you go to 40, that is a printable character. So I'll go to 40. So 40 here, we have here. So 40 is the left bracket. So I'll print. So 40 is this one. Sorry, only the left side bracket. So in place of 40, I'll be printing this, and 255, as you guys did till now many times, XFF. So at the end, that will be the value. So this is the byte array. In that byte array also, we'll be getting the values in this format only. And then moving on, if I want the internal values, I'll again use the for loop. Just how I used for the bytes, I'll use for loop. So for V in B. So B means this byte array data type will be. And first it will print 10 and then 20. So it will go on looping, right? So it will go to the next iterable value. And 10, 20, 30, 40, 255 will be printed with this for loop. So I got 10, 20, 30, 40 and 255. So these values are printed in this way. So now as byte array is mutable, so I can modify it, right? So I can update my values. So once created, I can update it afterwards. So I have given B of 0. So 0 means the first element, right? So 10 will be updated with the value 100. So B of 0 is equal to 100 means the 100 will be assigned. The 100 value will be assigned to B of 0, which is the value here, the 0 index element, that is 10. So in place of 10, it will be updated as 100. So let's run this updation. Now updation is done. If I try to print the internal values again with the for loop, if you see here, the 10 value, which is before, it is 10. Now after assignment, it is updated to 100. And to find the memory address or to find the type, I can use the ID function and then the type function. So this is the memory address location in which the B variable is stored, and it is of a class byte array. And then moving on, we can also perform indexing and slicing, right? Just a second. So let's just write positive indexing. Okay, so first index will be 0, and then 1, and then 2, and then 3, and then 4. When it comes to negative indexing, it will start from right to left, right? So from -1 it will start and it will go to -2 and then -3 and then -4 and then -5. Okay, so if I try to print -1 value, which is -1 is 255, we'll be printing 255. If I try to print the positive index 2, so this is 0, 1, 2. So that will be the value 30. So B of 2 will be printing me a value 30. And here, so this is just the reversal of string. So as it step value is negative, we'll start from right to left, and beginning index is default and ending index is also default. So to start from first and it till end of the elements it will move. So right to left. So it will print 255, 40, 30, 20 and 10. But as you know, it will print in bytes format, right? So here the /XFF is the 25, and then the left parenthesis is the 40 value, and then the /1e is 30, and /x14 is 20, and then it is updated to 100, right? Here. So the 100 value is D here. Here if you see 10, the 100 decimal number corresponds to D character. So that is why as your 10 value is updated to 100, so it will print D, which is the corresponding character D. So if you want to print directly the internal numbers, you can just use the for loop and print it. Then you will get all the correct values 255, 40, 30, 20 and 100, which is the updated value. Okay. So finally we'll learn about range. It will just take some time. So please be patient. So now we are learning about range. So okay, range is one of the predefined class name and it is treated as sequence data type. So range is very important for loops. So the loops like for loop, while loop, they'll use range. So range is used to generate sequence of integer values with an equal interval, or you can just give the step value and you will get the interval in that. And range is also immutable. You cannot modify it. So let's just say you want range of, let's say 1 comma, the starting one is 1 until let's say I want some million, or let's say just 10,000. So do you think range will store all these 10,000 values in your memory? It won't. So range will not store values in the memory. So range is also just lazy like us. So it will generate the numbers only when it is needed. So that is why it is memory efficient. So range is memory efficient. So range doesn't store values in the memory. It will just generate it when they are needed. So when this is called, then it will generate the values. It will not store any values inside. So range is, it supports the operations indexing and slicing operations, and it is immutable to be memory efficient. So for example, we have three syntaxes for range. So range will get just give this end index or stop index. So till that index -1 elements it will print. And you can also give like the start element and the stop element value. And you can also give start value to the stop value and the interval value, the step value. So let's move to the coding part. So you'll be having better idea about it. So now we are going to run range, and first syntax is the variable name equals to the range function of the value till which value you want. So it will print 0 to value minus 1 elements. So now I'm printing r equals to range of 6. So I can use it in this way, range of parenthesis. Inside I want elements till 6. So 6 will be like excluded. So the value will be from 0 to 5. So let's print it. So here the values, basically it will be saved as 0 to 6. So when you want to print all the internal values, it will be printing directly, right? It won't store any elements. So when it is called, it will be printing. So in a for loop, I'm trying to print the values in the range, that is 0, 6. So 0 to 5 elements will be printed. So first, our range will consist of the elements 0, 1, 2, 3, 4 till value minus 1. So value here is 6. So till 5 it will be printed. So first in your for loop, it will point to 0. So 0 will be printed and it will move next. As it is a loop, it will move to the next value. Then it will print 1 and then 2 and then 3, 4 and 5. So this is how it will print values. So if you can directly use it in the for loop also. So for v in range 11. So what happens here is, so range 11 will be consisting of the values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So as it is 11, 11 minus 1 till there only it will be printing. So when you try to print it using for loop, it will print all the values line wise. So 0 to 10 will be printed. So there is a syntax too. So variable name will be equals to the range of start value comma stop value. So this syntax gives the range values from start to stop minus 1. So here we have a range of 100 to 106. So what values it will be? 100, 101, 102, 103, 104 and 105 because the stop minus 1, right? So 16, 106 minus 1 will be 105. Till there only it will be printing. So internally it will just store as 100 comma 106. So if I want the all the elements in that range, I can use a for loop again and it will print 100, 101, 102, 103, 104 and 105. And directly also I can use it in a for loop. So here we have a range. The start value is 90 and the stop value is 101. So it will print values from 90 to 101 minus 1, which is 100. So all the 10 values, 90 to 100, it will print. So if I print it, so as you can see, it will start at 90. It will go on iterating to the next numbers. So 90 after 91, 92, 93 and so on till 100 because the stop value minus 1. Till there only it will print. And then the third syntax, we have a variable name equals to range of start, stop and step. So same as the step value in the strings we learned. Step value is like the interval where we'll skip it. So the syntax will give values from start to stop minus 1 with equal interval of step values. So if you see here, the range start value is 10. So 10 will be the first value, then 11, 12, 13, 14, 15, 16, 17, 18, 19 and only 20. 21 minus 1, right? 20. But the step value here is 2, right? So what happens is, first it will print 10 and from 10 it will check 1, 2. Step value is 2, right? So from 10, the element, first element, it will check the second element from that. And from 10, 1, 2. So it will print 12. And from 12, it will check the next second element from it. So 13, 1, 2. So this is 1 and this is 2. So it will print 14 now. And moving on, 1, 2. So it will print 16. And step value is 2. So 1 and 2, it will print 18. And moving on, it will print 1, 2. So it will print 20. So these are the values this range consists of. So if I try to print it, the values in this variable R is 10, 12, 14, 15, 16, 18 and 20. Because the step value is 2, it is printing that in that way. You can also take directly. So 100 is the starting value here and 151 is the stop value. So the values will be from 100 to, so the values will be from 100 to 150 minus 1, which is 150. So from 100, here direct step value is 10. You can just calculate it, right? So from 10, what will be the 10th value? It will be plus 10, right? 110. So the values will be 100 plus 10, that is 110 because of the step value 10. And then from 110, so first it will print 100 and that step value is 10. So plus 10, so 110. So from 110, the 10th element will be 110 plus 10, which is 120. So from 120, the 10th element will be 120 plus 10, that is 130. And then similar way 140 and then 150. Okay, so it will print these values directly. You can use this range function in your loops, that is for loop. So that is why your range function is important for loops. So as you can see here, the step value is 10, right? So that's why it printed 100, 110, 120, 130, 140, 150. In the same way here, we have a range value of 3. So from 1, I'll just do it. So from 1, the step value 3, right? So 1 plus 3. What is 1 plus 3? 4. So that is the third element. Easily you can calculate in this way. So 4. And then, so 1 comma 10, right? So it will print values from 1 to 9 only. So after 4, if you take step value of 3, so 4 plus 3, that is 7. 7 comma 7 plus 3 will be 10, right? So that will be out of loop, like the out of range value. So till there only it will print. So we got 1, 4 and 7. Okay. And then we can also use indexing and slicings in that. So the values from 100 comma 150, 1 comma 10, the values are 100, 110, 120, 130, right? So the indexes will be 0, 1, 2, 3, 4, 5. So if I want to get the value 0, that is the first element, which is 100. So we'll get 100. And then third index. So third index will be the value 130 here. So we'll get the value 130. And then minus 1. So from backwards, the first element is minus 1 index element, right? So 150 it will print. 150. And then minus 3 means, so minus 1, minus 2, minus 3. So 130. So 130 is the minus 2 index element. So it will print 130. And then we would done the slicing part. So here, so 2 is to 5 means we'll print 2, 3 and 4. Your ending index will be excluded, right? So till 2 to, that is beginning index to end index minus 1, 4 only it will be printing. So 2 to 4 only it will print. 120, 130, 140. So if you print this, so the range would be from 120 to 150 with a 10 step value, right? So if I want internal values, I can use a for loop and print it. So 120, 130 and 140. So here I'm trying to assign values, but range is immutable, right? So that is why you cannot assign values. So we'll get an error, type error. So in the above values, the step start, stop values, all indexes must be the values of integers only. They should not be in float because our indexes will be in integers only, right? 0, 1, 2, 3. So in that way only we should give. Float values are not possible. So this is the last part. We'll end in some time. So please be patient. So we want to generate sequence of 0 to 50, sorry, 0 to 5. So how I can generate it? I can use range of 6 directly. Then it will print the sequence of 0 to 5. And I want the elements from 1 to 10. So I can use 1 and the stop index -1 will print, right? So till 11 I will print. So range of 1 comma 10. I'll get the sequence from 1 to 10. So 1 comma 11 will give you the values 1 comma. So 1 to 11 minus 1, that is 10. It will print that. So here step value is 5, you can see. So 5 values difference are there here. So what you can do is you can give the beginning index, the value you want, that is 10. And then end index should be the value we want 50 at the end, right? So 51 you will give. So that 51 will be excluded until 50 it will print. And the step value, so the difference here is 5, right? Between this 10 minus, so 15 minus 10, 5. 20 minus 5, 5. 20 minus 15, 5. So step value is 5. So you can give 10 comma 51 comma 5. So in that way I will get the elements from 10 to 50 with the step value of 5. In the same way, we can do this, and I want to generate the sequence in a reverse order, let's say from 10 to 1. So first the beginning index I'll give as 10 and the ending index will be 0 because 0 will be excluded and till 1 it will print. So 10 comma 0 minus 1 as it is reversal, right? So it'll like the step value, you'll just add it. So 10, step value is -1. So difference here is -1, right? So for the first value, step value you will be adding basically. So 10 plus of -1 will be 10 minus 1 only. So it will print 10, 9. And then 9 minus 1, 8. 8 minus 1, 7. 7 minus 1, 6. So that way you can just add your step values to the beginning index and keep on going, getting the next number. If it is minus value, if you add it, basically subtraction only will happen. So here also I'm trying to generate 50 to 10 with a difference of 10. So the beginning index will be 50 and till 10 I should write. So we'll give 9. So 9 will be excluded. So the value still 10 will be printed. So -10. So first it will print 50, that is beginning index, and -10 will be 40 and 40 minus 10 will be 30 and so on, and it will print till there. So that is the stop value you'll get that way. So in the same way you can print the values. So here, so I can take directly the range of values from 50 to 56. That is, it will print 50, 51, 52, 53, 54, 55. So -1 means last element, right? So it will print 55. So in this way also I can perform indexing. So from the range of 50 to 56, I want to get the first value. So that's why I gave each to 0. So it will give the elements would be 50, 51, 52, 53, 55. So 0 index will be first value, right? So it will print 50. And so from second index, that is 0, 1, 2. So 52 will be the second index. Till end of string, I can print 52, 53, 54, 55. So it gave range. If you see here, if I want the internal values, I can use a for loop. And I can print this in this way. So I want reversal of string, I can just directly use range is to the square brackets. Reversal means we'll use this, right? So -1 means negative, from back to front it will start. So it will print from 55, 54, 53, 52, 51 to 50. So in that way, your values will be printed. So range is basically used for getting the multiplication table generally. So what I'm doing is I can take some variable you can take this from user also, or you can just give it yourself. And for I in range 1 comma 10, sorry, 1 comma 11. So your basically tables are from 1 to 10, right? So you'll multiply your number with 1 till you will get 10. So here I'm using the range 1 comma 11. So 1, 2, 3, 4, 5, 6, 7, then 8, then 9. So 11. So 11 minus 1 is 10. So I'm getting these values. Here in the print, in the place of n, I'll use 5. So 5. I'll print a string that is x, I. So here I value, first it will correspond to 1, right? So 5 into 1 it will print, and my string it will print. So commas will separate your characters here. And then n into I. So here n firstly is 5, right? And your I will be pointing to 1. So 5 asterisk 1. So 5 into 1 basically the calculation. So you'll get 5 here. In the same way, it will move to 2 and 5 into 2 and then 3, 4, 5, 6, 7, 8, 9, 10. So in the same way, it will print all the other values and then you'll get your table neatly. So in this way, so first you'll print your n value and then string x. To neatly understand it, you'll keep string x and then your I values from 1 to 10. I use the range to get that values and then equal to your string again. And then I'm performing n into I operation. So n will be given from the user input or your hard coded, and I will come from your range values. It will move from 1 to 10 and 5 into 1 to 5 into 10 it will know. So 5 into 10 is 50. So today we got to learn about the data types, which is sequence data types. So we've learned about bytes data type, byte array data type, and range data type. So bytes is not mutable, that is, it is immutable, and bytes is byte array is mutable. So that's the difference between those two. And range is used to get the range of values from the start and stop index or just the value. You can give the value. Okay, so this is how your sequence category data types are used to store a sequence of values. Yesterday we learned string. Today we completed the remaining. Tomorrow we'll be learning the next category, which is list category data types. So that's it for today, guys. If you have any questions, please put it in the chat box. As you've been listening to the classes, if you like the classes, please subscribe to our channel and hit the like button. And that's it for today. We'll meet again tomorrow.